Hello viewers, welcome back to BakoMaths, and today's lesson we'll be looking at how to find the inverse of a matrix using Gauss Jordan elimination. And so if you have not subscribed to this channel, kindly subscribe for more updates. Let's get started. And so we have this matrix that is A is equal to 1 2 3 1 1 2 0 1 2, and we want to find the inverse of this matrix. And what Gauss Jordan is saying that is that if we have a matrix, we can augment it by the identity matrix, and by applying row operations we can end up getting the identity matrix on the left hand side, and then the matrix we get on the right hand side now becomes the inverse of the given matrix. So basically you want to augment this matrix by the identity matrix, and after applying row operations, the new matrix we get on the right hand side together with the identity matrix on the left hand side, that matrix on the right hand side becomes the inverse of the matrix we want. And so since this is a 3 by 3 matrix given to us as E, we can write our identity matrix as a 3 by 3 matrix. So in that case we are going to have 1 0 0 0 1 0 0 0 1. And so straightforward, we are going to augment it with the matrix given to us. In that case, we have the matrix A first, that is 1 2 3, and we have 1 1 2, and we have 0 1 2. And when we augment with the identity matrix, we have 1 0 0 0 1 0 0 0 1. So it means that we'll have to change this 1 to 0. This place is already 0, so no problem. This place is already 1, and this side is 2. We have to change to 0. We have to change this side to 0. We have to change this 2 to 1, change this 2 to 0, and change this 3 to 0. And that becomes the focus for today's video. And at the end, as we apply the row operations, its effect may happen on the matrix we see here, and that matrix now becomes the inverse of our matrix A. And so by applying row operations, then since we want to make this 1 to 0 by considering the pivot in row 1, then we can say that row 2 is equal to, now to get the formula easy, let's do this simple illustration. And so we are considering row 1 and row 2 itself. We know that in row 1 is 1, and in row 2 is also 1. And so when we subtract, then we are going to get minus 1 plus 1, that is equal to 0. And so you can have our formula as minus row 1 plus row 2. So minus row 1 plus row 2 becomes our formula. And we continue, the next element in row 1 is 2. We are subtracting, and row 2 is 1. And when we add, we have minus 2 plus 1, that is equal to minus 1. Now we continue, for row 1 we have 3, we are subtracting, and row 2 we have 2. And so we have minus 3 plus 2, that is equal to minus 1. The next element in row 1 is 1, we subtract, and in row 2 now we have 0. And so minus 1 plus 0 is equal to minus 1. The next element is 0, and plus 1, we have 0 plus 1 is 1. And we continue, the next element is 0, and in row 2 is also 0, so we have 0 plus 0 is basically 0. And this becomes the new set of elements for row 2. And so you can rewrite our new matrix as, so in that case we maintain the same values for row 1, and that becomes 1 2 3 and 1 0 0. And row 2 now we have 0 minus 1 minus 1 minus 1, and we have 1 0. So maintain the same values for row 3, and that becomes 0 1 2 0 0 1. And at this point it means that we'd have to change this minus 1 to 0, and in so doing we are going to multiply row 2 by negative row 2. So that is multiplying row 2 by -1. And at the end, we can have our new matrix as. So in that case, it also means that we're going to maintain the same values for row 1. In row 1, we have 1, 2, 3, 1, 0, 0, and 0, 1, 1, 1, -1, 0. And row 3, maintain the same values, and we have 0, 1, 2, 0, 0, 1. Now the next step is the fact that we want to make this one here 0 by considering the pivot in row 2. And since that effect is going to happen in row 3, we can say row 3 is equal to. Now how do we get the formula? By a simple illustration, we are considering row 2 and row 3. And so that effect is happening at the second column of the matrix. And so we can write it as 1 and 1. And so what must we do so that these two elements goes to 0? So basically when you subtract, you are going to get -1 plus 1 gives us 0. And so our formula now becomes minus row 2 plus row 3. So you can write it as minus row 2 plus row 3. And our first element is 0, 0. So we can look at how the formula is going to be applicable to this element. And we have 0, 0. So when you subtract, you are going to get 0. It continues for the next element, that is 1, 2. And in row 2, we have 1. So when you subtract and we add to row 3, at the end, we are getting 1. And then it continues for row 2 now. We have 1, we are subtracting. And in row 3, we have 0, we have -1 here as our answer. And when we continue, we have -1 existing. And remember that we are subtracting, and in row 3, we have 0. And so when we add, we have 1. Then the last one is 0. And in row 3, we have 1. At the end, we are having 1 here. And so this becomes the new set of elements for row 3. And here's the case. We can write our new matrix as. So we maintain the same values for row 2 and row 1. And in row 1, we have 1, 2, 3, 1, 0, 0. And for row 2, we have 0, 1, 1, 1, -1, 0. And row 3 now becomes 0, 0, 1, -1, 1, 1. And so our next is the fact that we want to change this one in row 2 to 0 by considering the pivot in row 3. And so since the effect is going to happen in row 2, then you can write row 3 is equal to. Now how do we get the formula and how it's going to be applicable to the rest of the elements? With that, we can follow our normal routine. And if that happens, then it means that we are going to consider row 3 and row 2. And then our focus is on this 1 and 1 in both row 2 and row 3. So we have here as 1, 1. And so what must we do so that these two elements goes to 0? Simply, if you subtract from row 3 and add to row 2, then means you're going to get -1 plus 1 to be equal to 0. And so our formula now becomes minus row 3 plus row 2. And so I can write here as minus row 3 plus row 2. And that becomes our formula. And so it's going to be applicable to the first and second element. And then it follows. So in row 3 now, we know it's 0. And even if you subtract to 0 and we add, we are going to get 0. Now the next element in row 3 is 0. And so we have -0. In row 2, we have 1. And so we are going to get back 1. Now the next element is what we have done here. And so we continue. And in row 3, we have -1. But there is existing -1 here. Minus, so we bring it. And in row 2, we have 1. And so when we add, we are going to get -1 is 1. And so we have 1 plus 1. That gives us 2. Next element here in row 3 is 1. And we are subtracting, we bring it. And remember, in row 2, we have -1. And so we have -1 minus 1. That is -2. Now next element in row 3 is 1, we are subtracting, and for row 2 we have 0, and so we have minus 1 plus 0. That gives us minus 1, and so this becomes the new element for row 2, and so we can write our new matrix as, and so at this point we have our new matrix as, maintain the same values for row 1, and we have 1 0 1 minus 1 2 0, and for row 2 now we have 0 1 0 2 minus 2 minus 1. Maintain the same values for row 3, and we have 0 0 1 negative 1 1 1. Now the next ideology is the fact that we want to change this 1 to 0 by considering the pivot in row 3, and since that is going to happen in row 1, then we can say row 1 is equal to, now how do we get the formula? We can get it by following our normal routine, and so with that we can simply write here as, we are considering row 3 and row 1, but then our focus is on this one and that one, and that happens to be the third element in the column. So we have 1 and 1. So what must we do so that this two element goes to 0? So when you subtract from 1 and add to this one, we are going to get 0, and so our formula now becomes minus row 3 plus row 1. So minus row 3 plus row 1. Now let's see how the formula is going to be applicable to the rest of the elements. And so in row 3 the first element is 0, and row 1 is 1, and so when you subtract, you are going to get back 1. The next element is 0. If you subtract, you are going to get 0, and in row 1 is 0, and so we have 0. The third element is what we have done here, and in row 3 the next element is minus 1. Now we bring our minus, and in row 1 we have minus 1 here, and so when added we are going to have, that is 1 minus 1, and we are getting 0. Now we continue for row 3, and row 3 we have 1, and when we subtract and we add to the next element in row 1, that is 2, we are getting minus 1 plus 2. That gives an answer of 1. Now the last element in row 3 is 1, and then we add to row 1, that is 0, and we are having 1 here, and this becomes the new set of rows for row 1. And so that can happen in writing a new matrix as, and so we have here as, in row 1 1 0 0, and we have here as 0, and the next one is 1, and the last one is 1, and we maintain the same values for row 2 and row 3. But remember, we said the formula is minus row 3, and so we should have brought the minus here, so that at this point we are going to have minus 1, and so to correct it, then the original answer should be minus 1 here, and so it means that in row 1 you should have minus 1. Maintain the same values for row 2 and row 3, and we have 0 1 0, we have 2 negative 2 negative 1, we have 0 0 1 negative 1 1 1, and so this becomes our final answer. And so if we can remember, in the beginning we said that we are going to apply row operations such that the matrix we get on the left hand side becomes the identity matrix, and whatever we get there on the right hand side becomes the inverse of our matrix. So therefore we can see that, therefore A inverse by applying Gauss Jordan elimination is equal to the matrix 0 1 negative 1 2 negative 2 minus 1 minus 1 1 1, and this becomes our final answer for the inverse of the matrix. And so this ends today's video. So thanks for watching. Kindly like, comment, subscribe, and share. BakoMaths, thinking beyond infinity.